Good evening, everyone. I, Indraja R, of third semester, take immense pleasure to welcome today's resource person, Ms. Pavitra Bhade. Ma'am has completed her undergraduation in Bachelor of Engineering in Electrical and Communication Engineering and post-graduation in Computer Science from Goa Engineering College. Ma'am has worked as technical analyst in Infosys for a period of 2 years and as teaching assistant in Indian Institute of Technology, Goa. Currently, Ma'am is pursuing her Doctor of Philosophy from Indian Institute of Technology, Goa. Thank you for accepting our invitation, Ma'am. I welcome you once again. Today's session is based on Pavitra Ma'am's academic journey and introduction to networking. Now I request Ms. Pavitra Bhade to take over. Over to you, ma'am.
Over to you, ma'am. Thank you so much, Indraja and the Admins Lab people to allow me to have a session with you guys. It's a very interesting thing to happen. The last time's session also was very interesting. I could see a lot of enthusiasm amongst you people. So it's good to have a session again. So, okay, I've made a presentation. So, can I share my screen? Yeah, I think I can. Can you see the screen? Hello?
Yes, ma'am.
Is the screen visible? Hello?
Yes, ma'am, it is visible.
Yes, it is visible. Okay, fine. Okay, so I've just taken some funky kind of template just to make this session a little informal so that let's have a discussion or interactive kind of session. I just wanted this to be that way because you all can ask me any clarifications or anything regarding your academic journey as well so that we can make the best out of this. Okay. So let me just start. So this is what I will be covering in today's session. So there are basically three things. One is my academic journey from my bachelor's degree because I feel my journey is slightly having a lot of twists and turns. So that will be a good thing to talk about. Also, slightly, I would also introduce you to my PhD research interest. What's domain I have selected, and if you guys also are interested in anything like that, you all can contact me anytime. And also, I will talk about introduction to networking, just the basic fundamental concepts. Okay, so let's start with my academic journey. So this is my career path. So in 2010 to 2014, I've done my bachelor's of engineering in electronics and telecommunication from Goa College of Engineering. So I'm based in Goa. I'm from Goa. My hometown is here. So I opted for the Government College of Engineering to do electronics and telecommunications. Now, at that time, the hype was that ETC is the best stream one should go for. All the top rankers should go for that and all that. So instead of thinking about what are my actual interests or what I really want to do in life, I just went with the crowd and I opted for this stream in this college. And I won't say it was a rough journey or anything. It was kind of good. But at the end of my bachelor's, I was still confused as to what I actually want to do in life. Okay. So instead of going for higher studies or anything, I just opted for the job that I was placed in. It was a job of networking engineer at Infosys. So I went for that job and I worked there for 2 years. So initially there was a training phase in Mysore. Since we were students from electronics and telecommunication, we needed this training in computer science That was hardcore training in Mysore, and then we were placed in Pune. After that, I opted to resign from Infosys and then do my master's. So for my master's, instead of doing my master's in electronics and telecommunication, I did it in computer science. And again, I came back to my hometown in Goa and I did it from the same college, which is Goa College of Engineering. So after my master's, for a year, I worked as a teaching assistant in IIT Goa itself. Till then, I was not very sure of going for PhD as my career because I was sure of one thing, that I want to teach in future. I want to go in the academic profession. But then I realized that if you want a full-fledged career in academic profession, PhD is compulsory. So after working as TA for 1 year and after having the experience of the environment of Indian Institute of Technology, that gave me a boost in joining that same institute as a PhD student. So right now I am pursuing my PhD at the same institute. Okay, so this is my career path, which is slightly not as smooth as one would think of. It's just having some decision makings at every point of time as to what I have to do based on the past experiences. I changed my paths. So that's what I wanted to show. Now you can see from my career path that I've switched from electronics to computer science. Now, why I thought of that is that when I was studying as a bachelor's in electronics student, I realized one thing, that some of the core subjects were not my cup of tea. I literally couldn't understand anything in those subjects. And here I would like to interrupt if any one of you at any point of time wants to ask something. In between, you can interrupt me, or then I can take questions at the end also. Anything as you wish. Okay, so let's not keep it very strict. Let's keep it informal. So yeah, let me continue. In my electronics, I could see that there's no way I can take this domain as a domain of higher studies because it was not very pleasant when it comes to all the subjects. If I take few subjects were very interesting, no doubt, but not all. So that's why I didn't think of much with respect to higher studies, and I directly went for the job at Infosys. Now, when I was placed in Infosys and when I was in Mysore, that's the time I got to know the introduction to most of the computer science subjects. We were trained in Mysore. So that's when I gathered this interest in computer science. I could literally work till late hours at night and study and learn more than what is actually the syllabus allotted to us. So that was all out of interest. That's what pulled me towards gaining more and more information in software area. Okay, so again here, not all the subjects in computer science were more concerned to me. A few of them were very much interesting. And to my luck, I could sense that computer architecture and computer networking, these are the two domains which I was really interested in. And luckily, I was placed in a project at Infosys which was majorly dealing with computer networking. So that's how it gained a lot of interest. I gained a lot of interest in that subject, and I worked like anything. I was also awarded as one of the best employee in that team. So here I would like to mention one thing. So here I would like to mention one thing. Right now, there is a lot of problem when it comes to employment and everything. Even if you have a lot of degrees, employment is very problematic right now. You don't get the right kind of jobs. You are one in the crowd. So it's okay if you can handle such life, but if you want to stand out, I would like to say that since you're in your undergraduates right now, so now itself you have to find out which is your area of interest. Now, one important or easy tip to find out your area of interest is that you have to think in what domain, if you work every day, you will be happy. Like someday you will wake up and you have to go to office. It should not come to your mind that, "Arey, aaj kya hai? Aaj mujhe ye kaam karna hai. I don't want to do this. Why am I in this job?" You should not think like that. So you have to find your area of interest in that way. You should be happy doing it throughout your life, because till the age of 60 you will be working in that field. joined to one particular career, you'll be bound to it. It is a part of your life. Most part of your life you'll be spending in your office. So you have to decide what is your area of interest. And also, you have to find out one particular area of expertise there and then sharpen that. Because after a few years, you have to be able to tell people what you're good at. You should not keep on touching just few domains here and there. You have to be master at one particular domain, so that adds that extra factor in you which separates you from the rest people at your workplace. So this is what I got to know from my career journey. So from bachelor's in electronics, then Infosys software training, then master's in computer science, then comes my PhD. So I opted for a domain in PhD which was a mixture of both my electronics as well as computer science knowledge. Now I did that because I didn't want any of the knowledge to be a waste, because anyhow 4 years I had invested in bachelor's and 2 years in masters and also 2 years in software industry. So I wanted both expertise to be used. So I'll talk about the journey of my PhD research area. So now, if any one of you is opting for PhD in future years, now as of now, you might think that, oh God, PhD is very boring. It's like desk job, like reading and reading to for many more years now. We can't handle undergraduate as of now. Who is going to do PhD? All that you must be thinking. But then, if any one of you wants to go in academic career, let me tell you now itself, PhD is a must. And you can do PhD just after your undergraduation. You need not do masters. You have to just answer a gate for that. I didn't know that at my time, so I went through the longer route. So you can do your PhD just after your graduation. So for my PhD research area, as I told you, I went for both the domains of electronics as well as software. So my current research area is focusing three broad domains. One is security of computer architecture, second is attack and defense mechanisms, and third is secure process architecture. Now, in layman's term, what I'm working on is, now we know that there is digital world booming up right now. Every device today is connected to the internet. Initially, it was just our desktops and phones, but now even the refrigerators, the washing machines, our cars, everything is connected to the internet. So all the processors in all these devices have to be very secure. Even the medical equipments which are being used inside the body, some processors are also injected into the body. Those also have to be very secure, because someone might tamper them to kill you. So a lot of advancements are happening in terms of technology, which are killing the security part of it. So we need to take care of the security aspects as well. So I am basically working on how to make processors more secure. So this is one area which is in boom right now, along with artificial intelligence and machine learning and all of that. So security of computer architecture is what is I'm working on, and it involves computer architecture, which is kind of software as well as electronics part of digital logic and all is involved in that. And security deals with all the software and OS interfering with the processor to cause certain secure enclaves, so that victim's execution does not interfere with the attacker's execution. So all that takes care. So it's a blend of both electronics as well as computer science. So you can think of all that also. You need not stick to only one particular thing. You should broaden your area. So this is what I wanted to talk about my PhD research area. Any one of you is interested in such domains can contact me anytime. We can have a discussion or anything. So next, let me come to the main thing, that is introduction to networking. Now, as you all know, I was bachelor's in electronics, so we just had one subject of networking, and that too, since I was not very much happy with my bachelor's, I did not understand much, frankly speaking, whatever was taught to us in the college. But when I went to Infosys, that was the time I was fascinated, because the way they taught us there, it was in relation to the real world environment. So sometimes what happens is the bookish knowledge, you can't relate it practically. Then it becomes just mugging up. And and mugging up does not lead to any good information. You have to, at the end of the day, give some deliverable. You should not only be able to do things, you have to be capable of producing some output from that knowledge. So that's what happened to me when I was trained at Infosys. So I was selected in one of the projects known as Juniper Networks. Now, Juniper is an American multinational company. It deals with networking products. Okay. So my team majorly focused on designing routers, switches, firewalls, and networking solutions. So this job was really fantastic. It was highly technical, and there were many promotions also allotted to us. But unfortunately, at the end of my 2 years tenure, this project had to go out of Infosys, and that's when I decided that I need to switch and pursue my higher education. If that was not the case, I would be, I think, stuck with this Juniper Networks itself now also. But it was kind of fun and I was enjoying it. I wouldn't mind that journey as well. So let me just start by asking, what is networking? Now, initially in previous years, computers used to communicate with each other. Like one person used to send some mail or some information, and the other computer used to receive it. And that was one at a time also. Like only if you send, after some time, the receiver would send you the response back. It was half duplex kind of. But now the networking has boomed so much that every other device around you is communicating somewhere or the other. Okay, there is GPS involved, there's Bluetooth, everything, that in every way there is communication evolving everywhere. And more research is also being done. So further in future, you might even think of your tables and chairs also communicating with each other as per your posture, and they are, arranging themselves. So everywhere there will be communication. So they have to interact with each other. Now, this interaction and connection between all these devices is networking. Okay. So, networking is connection of devices to pass data from one to another. This is the basic thing of networking. Now, since a number of devices are involved, we don't know what is the configuration of these devices, on what OS they are built on. So there are a lot of heterogeneous environments involved in this communication. So in order to provide some standard way of communicating, they should follow certain protocols. So if there are no protocols or if there are no certain standard rules laid out, then such heterogeneous devices won't be able to communicate with each other well, and there will be just pure chaos. Okay, so to allow a lot of flexibility and to allow any different kind of devices to interact, a set of rules have to be followed. Okay, so there are multiple rules. Now, along with following different rules, there are also certain dedicated devices in the network. Not only the end products now are laptops, our phones, and our refrigerators, our ACs, whatever smart devices are available right now, these are the end products, or these are known as the hosts. So they generate data and they receive data. So they are high-end products. But there are also other products which don't have anything to do with the data. They are just transferring information from one point to another. So those devices are also there in the network. We will talk about the different devices involved. So there are dedicated devices to perform dedicated tasks. So everyone has to follow these protocols. Only then there will be a standard communication laid out. Now, to cause this communication between one point to another, addressing is very important, because otherwise there will be no certainty who is receiving the data and there might be breach in information. So, addressing is the main thing that is there in communication. Like verbally, we have names, so even the devices have addresses. Now, one address is not enough here because there are a number of devices. Everything in this world is connected today. So, there are three sets of addresses which we use in networking. The first one is the MAC address, MAC is Media Access Control. So this address is 48 bits. Now this address is allotted to every device which is connected in the network. Every device has this address and it is hard coded to the device. Okay, it is not logical, it is the physical address. So you purchase a laptop, you purchase a phone, you purchase a AC or whatever, purchase a car with a processor, anything, it will have a MAC address. So this is manufactured and hard coded in your processor. So these 48 bits of the MAC address itself has a few bits which represent who is the manufacturer. So using that MAC address itself, you can find out which company it is, when it was manufactured and everything. Okay, so this address is the hard coded address. That's the MAC address. Then you have the IP address. Now we have IPv4, which is 32 bits, and IPv6, which is 64-bit addresses. Now, IP addresses, now you may say if there is already a unique address using MAC address, then why do we need IP addresses additional? Now, IP addresses are also used to identify different devices in the network, but IP addresses are logical addresses. They are not physically attached or hard coded to your device. These addresses are assigned based on where you are in the network. Now, for example, your institute, all the laptops which are there in your lab, they will have a, a range of IP addresses. So they belong to one particular network or subnet. So that's how it becomes easier to route the data based on the different networks. Whereas when you take MAC addresses, if I sit with my laptop at my house, or if I sit with my laptop at your institute in your lab, my MAC address is not going to change. That will be constant. So the routers on the way who are sending me data when I'm sitting at home or when I'm sitting at your institute, they will face problem to route the data because MAC address is not changing with my location, but IP address will change because it's logical. So the routers or the servers will find it difficult. It is easier to route the packets. There's a proper hierarchy when you talk about IP addresses. Like all the addresses group together to form one particular network. So that's how you name different devices based on IP address. Then we have the port address. Now we have very high-end devices, like there are multiple operations and multiple applications running on one system. So if I open a Gmail tab and if I open a YouTube tab on my system, there are these two different things running and they will contact two different servers for information. So when the data from these servers are coming to my laptop, they will come through different servers, but they will come to the same laptop. So which data has to go to which application, that will be decided by the port address. So that's why these three addresses are very important for a proper communication in the networking domain. So I'm not going deep into these three addresses, especially MAC address has different fields assigned to when the device was manufactured and when the what is the manufacturer company and all that, which is assigned in that 48 bit. So I'll not talk much into it because it's just introduction of the domain. Now, as I had mentioned that there are certain protocols or certain standards to be followed for the communication to take place smoothly, then ISO OSI model is one of those standards. So there's a TCP IP model also, which is derived from this ISO OSI model. So I'll talk about this model today. So this is a 7-layer architecture. Okay. Basically, what happens is when we communicate with different devices, I generate some data from my laptop and that data has to go to the Google server. The Google server will process that data and send me some response. Now, this one particular communication of sending and receiving that data is not so simple as it looks like. It has to go through a series of layers or a series of steps so that certain information is added to that data so that on the way all the networking devices understand what this data is meant for, where it is heading towards. All that information has to be appended along with that data. Now, this appending of information happens within all those layers. Okay, so the first layer is the application layer. The application layer is the layer that generates the data. So if I'm writing down a mail, all that content of the mail, the data which is generated, that belongs to the application layer. Then comes the presentation layer. As the name suggests, presentation layer takes care of how this data has to look like, because one end we will have a laptop and other end maybe we have a phone. So the way the data looks on a laptop and the way it looks on a phone is different. So the formatting and all other information is added by the presentation layer, so that accordingly all the changes are done on different endpoints. Next we have the session layer. Session layer takes care of keeping the dialogue continuing. So if I'm communicating with someone, I said hi, the other person said hello, then I reply again, how are you? So it is one dialogue or one session which continues. So all these independent messages should not be treated individually. Even on your WhatsApp, you see that one after the other, it is contained in one particular session. So session layer takes care of binding all this information together. It is like a cloud is formed for one session altogether. Okay, so that is taken care by the session layer. Then we have the transport layer. So as I already mentioned, when I'm opening YouTube or I'm opening Gmail or 2, 3 different tabs on my laptop, each one is a separate application. So when data is generated by all these applications from one single laptop, these different applications have to be identified by the port number. So these port numbers are assigned in the transport layer. Transport layer also takes care of the encryption or the security, not encryption, but the security, so that TCP and UDP are two famous transport protocols. So TCP is the connection oriented protocol and UDP is connectionless protocol. So TCP takes care that there is security involved in your system, so that only the one which is destined for the message will continue to have one TCP session, and only then that cloud or the session continues. So that takes place by the transport layer. Then we have the network layer. Now, as transport layer assigns port numbers, network layer assigns the IP addresses. So network layer basically does the job of adding the source and destination IP addresses, and it is majorly taking care of the routing protocols. So all the routing or transferring the data from one point to another, that happens using the network layer. Then we get to the data link layer. The data link layer is assigning the MAC addresses. So MAC address of the receiver and the sender both are written in the data link layer. Now what happens here is that if I'm sending one message from my laptop to say a Google server, then say I'm doing a Google search, then I don't know what is the MAC address of the Google server. So my laptop will not assign the MAC address of Google server in the data link layer. It knows the IP address of the Google server, that is the global IP address. In fact, instead of the IP address, rather I should say that it knows the URL. URL is Uniform Resource Locator. So that URL or the domain name, say google.com or facebook.com, we know that. So when I type that address, that gets translated to an IP address using the DNS. So every network, every internet service provider will have its associated DNS. So that DNS does the job of translating these names to IP addresses. So with that, I know the destination IP address, but I don't know the destination MAC address. So destination MAC address is not what should be in the data link layer. Data link layer should have the MAC address of the next hop, or when my message goes from my laptop to the Google server, on the way it hits many routers and many switches and other networking devices, and then finally it reaches the Google server. So on the way, whichever device it hits, all those interface MAC addresses will be updated in that data link layer. So IP address will be the final one, but the data link layer MAC addresses will keep on changing after every hop. Now the IP address also changes. That depends upon if the destination is having some security mechanisms applied to itself. Like some organizations, they don't reveal their internal IP addresses. They show some public IP. So when I'm generating data for that organization, I will send it for their public IP. But when it will reach their router, that IP address will change to their internal IP addresses. So that will be done at their end. So that is the only case when the IP address changes. Otherwise, MAC address changes at every hop. And then we have the physical layer. Physical layer takes care of sending the binary data. Okay, it is just the physical connection basically. So translation of the binary data into required voltages, the highs and lows, all the discrete signals, that will be taken care by the physical layer. So this is how one particular message has to go through multiple steps before reaching the final destination. Okay, so this is how a communication model is actually presented. So to the left, we have device A and to the right, we have device B. Now these two are laptops or desktops. So they are host machines. Since they are host machines, they will be generating some data for communication. Now, since they are generating some data, they have to work right from the application layer. So they're working on application, presentation, session, transport, everything. And they generate that full bunch of data and send it through physical. Now, before reaching device B, on the way they will come across the routers or switches or anything, any other networking devices which will help them in routing that data to device B. So on the way, these devices are just doing the mere transmission from one point to another. They are not adding any data or anything. So they don't work on the higher layers of application, presentation, session, and transport. They just work on network, data link, and physical layer. The router will check what is the destination IP address, and accordingly, it will transfer that data to that particular path. So it's just doing that role. That's why they are not working on all the layers. Okay, so this is how the communication takes place in a complex network. Now, basically, when the data is transferring from application to other layers, what happens is that application layer will generate some data, some bunch of bits. Presentation will layer will take those bits and add its own header. This header, as I already told you, is the information of how this data should look like at the end location, the formatting and the fonts and everything involved in that. Then there is session header which will be added. This takes care of binding all the related datas to one particular conversation. Then there is transport layer that will add its own header. This header will include the port address or the application number, like which it belongs to which application. That particular information will be added in this header. The same information will go to the network layer and it will add its own header, which is the IP addresses of the source and destination. This information will be used in routing. Then the data link layer will add its header as well as trailer. So here there are two informations added. Header will be all the information of the source and destination MAC addresses and everything. And trailer will be the error correction codes. This checks for if there is any errors in the transmitted data. So there will be some parity checker or cyclic redundancy checker. All that will be there. So that is not highly error correction mechanisms for causing a lot highly secure application. You have to do some processing at the application layer, but this is just a normal check of whether the sent data is received correctly or not. Okay. And then the physical layer is going to transfer this entire information in binary over the signal, over the link in terms of signals. So at the receiver, the physical is going to convert it to required binary representation. The data link layer will check for which device it was meant to. The networking layer will also check for which exactly system in the network it meant to. The transport layer will check for the application. The session will check for this, the conversation session. The presentation will present the data in a particular format, and the data will be displayed to the receiver. So this is how the data exactly, the chunks are added and deleted when the communication is conducted. Okay. So this is the last part of today's talk. So I'll just introduce you to the networking devices. So these are the devices which are majorly used. Now I'm not aware of other devices which may be added now, but these are the ones which I'm aware of. So let me take one by one. So this is modem. We all know this. We use this. So modem is a combination of modulator and demodulator. So our laptops and our other digital processing signals, they generate data digitally. So, but when we transfer this data to other devices, we have to transfer it on analog links. So to convert this digital data to analog, this modulator is used. And at the receiving end, from analog to digital, we need to convert. So that's why this modem will be used. Now, this is how the communication takes place using model. Digital data generated by the computer is sent through modem, and then the analog data is sent through the public telephonic network, and then it is received at the other end on a modem, which again translates it to digital data and sends to the computer. Then this is NIC, which is network interface card. Now this is the card which is inbuilt on your system. This is the card which has the MAC address, hard-coded MAC address. Now it is an internal hardware component. It is also known as network adapter card or Ethernet card or LAN card. And it is the main thing that allows communication with other networking devices. So through this card, the data communication will happen. So this is how it is there on our systems. That is the RJ45 connector through which we connect the cable. And that's how the data transfer will take place from our system to the outer world. So that will have its dedicated MAC address. Then we have something known as repeater. Now, repeater is basically just working at the physical layer. It is only to regenerate signals. So when the distance is too much, we need repeaters in between to just regenerate the attenuated signal. So because of the length of the wires and everything, the signal becomes strength becomes very low. So that's when you need a repeater to just it actually does not amplify, but it just reproduces the entire data once again so that it comes back with its original strength. So that's what is the job of repeater. So this is, if the distance is too much, the repeater will see that the strength, original strength is maintained till it is received at the receiver. Okay. Then we have a hub. What the hub does is that it is the same as repeater, but when it receives data on one point, it just replicates that data and sends to other points. So you can see from the figure, there are three endpoints to the hub. One of them might be an input and the rest two are outputs. So whatever the input feeds data to the hub just copies it and sends to both the outputs. So it's just broadcasting any data which is coming to it. So it's just like a repeater. Repeater is just having one output and one input. Hub is having multiple outputs and multiple inputs. So at a time, only one input will be replicated to all the outputs. So this is the operation of hub. So from the left, you can see one data has come in, and then the hub just copies it and sends it to the rest systems. So it's just like a broadcasting point. Then we have a switch. The switch is also having a similar operation as the hub. But here what happens is there is dedicated destination or dedicated path chosen. So the switch takes a look at the MAC address. Now the switch will read the data link layer, the data frame, and check what is the destination MAC address. And on the switch, there will be a MAC table or MAC table maintained. So it will check what is the destination address mentioned on the packet, and accordingly it will check for the output port that will lead to that destination, and it will only send that packet through that port. So the difference between switch and hub is that hub will transfer the data to all the ports, but switch will only transfer to the dedicated port as mentioned on the packet. Okay, so initially the switch will not have all the information. The switch only has empty table. The switch through over the journey, over a time period of time, it will generate the table based on the incoming and outgoing packets. It will understand what MAC address is should be associated to which port. So based on that, it will generate the table, and accordingly it will send the required data to required ports. So this is the job of the switch. This is how the switch commercial switches look like. And then we have the router. The router is doing the same job as the switch, but the router will do it at the networking layer. So it will check for the IP address in the packet, and accordingly, based on its routing table, it will route to that respective destination. So it is checking for the IP addresses. So if you see here, you can see when the packet comes from the internet, first the router checks in which network it should pass through. It should go through the left or right network. Once it goes to one particular network, then internally it is the role of the switch to pass it to the required destination based on the MAC address. So the router will check the network based on the IP address, and then switch will check for the uh, respective endpoint host based on the MAC address. Then we have the firewall. So this is the last thing that I've included. This I've included because I have worked on firewalls at Infosys. So this is a very interesting device. This not only does the routing, meaning all the devices which we have seen before are the really required ones. Without that, the communication won't happen. That is the ones which generate data, which take your data from one point to another and all. But this firewall is something to do with security. So if you want some security to be built in your network, that is, you don't want some data from untrusted sites or untrusted zones to enter your zone, then you have to assign certain policies on this firewall. Okay, so it is the security device. What we were doing at Infosys was that we were generating policies, or we were configuring policies that if data comes from this particular device, you block it. Or if data comes from this particular device, it is very important data, so you give high priority to it. You don't drop these packets. So all that kind of internal, as per your requirement, customizations can be done on the firewall. So this is a very interesting device in your network. So yeah, that's it. I've included. So this is the overall picture of network in network devices in a network. So we have all the hosts which are connected to switch. There is something known as bridge also. So I didn't talk about bridge because for that I will have to introduce you to the topology of connection of LANs. There are different topologies. So ring topology, star topology. That's how the different devices will be connected at the data link layer. So when these different topologies transfer data from one to another, they have to transfer it using a bridge. So that's the only thing. It's similar to a hub or anything. It just transfers from one to another with the required conversion based on the topology. And then there is switch, then there's repeater if there is a longer distance. Then first your data will hit the firewall while going out. It will do the required security stuff, and then it will go out through the router. And if the data is coming into your network, first it will hit the router, it will understand it has to come in, then it will hit the firewall. And if it should not enter your network, it won't enter. And if it has to enter, it will enter through the firewall. Yeah. So that's all that I have included, since it is just the introduction part. So if anyone has any questions, you're free to ask me. I know it was a small session, but it's actually networking is one subject as a whole. So this is just introduction which I have included in this session. Hello. Hello, I'm not able to. Hello, yes.
I basically have a question. While you started your journey, you had many ups
Sorry,
and
I'm
downs.
not able to hear you clearly. Yes, yeah, I can hear. It's
All right, ma'am.
slightly having jitter, but still I can hear, yeah.
Okay.
Hello, ma'am. Am
Hello, yes, yes, tell me.
So my question is, while you started your journey, you
Hmm,
had many ups and downs. You are not sure
hmm.
to what to opt next. So what suggestion you want to give to us that we don't have such kind of problems in the future?
Okay, yeah, so one suggestion I would like to give you is when you're, yeah, is your question over or you want to add anything?
Well, then, that's it, ma'am.
Okay. Yeah, so what I would like to tell you is first of all, think what you want to do at your end point in your future. Whether you want to land up in some software job, whether you want to land up in academics, or whether you want to do some other kind of blogging or cookery, whatever. Nowadays, all that is also in fashion and everyone is earning quite well. So you first find out your end point. In my case, I was confused for that also, but I was sure that I will end up doing something which is either software job or teaching. No other thing apart from that. So, first and foremost in this journey, I would like to say, see that you have good marks in your career so that you have one job in hand as a backup. I would not say have exceptional marks or anything. Maybe your professors might disagree to me, but have proper presentable marks so that you clear the cutoffs for all the placements. That's it. And have one backup job. After that, you can think of your interest and all because right now financial stability is very important. So have one backup job, have decent marks, and then think what you want to do. Maybe if you're thinking of academics, then you decide if what is your favorite subject and accordingly PhD in that. If you're not having any favorite subject, then my advice to you, don't think PhD because in a PhD you're putting 5 to 6 years of your life into one subject only. So if you don't have any hardcore interest in any one particular subject or one particular domain, then don't even think of PhD. Your life will be like next to hell. So just as of now, clear all your exams in a pretty good manner so that you have your job at hand. And then you can think of other things and your interests and everything. Without a backup plan, I think it becomes very tense situation to think of even pursuing any interest because of the society pressures and everything. So just think of getting a job first of all through placements or anything, and then you can think of going ahead with any interest areas. So does that solve your question or you want to know anything?
Uh, Uh, Another question was how was the environment in Infosys? How was it different from when you were learning, in your academics? Then you joined the job. How was it different for you?
Okay, so what I would say here is that my training period in Mysore was same as the academic journey that we have in our college. it was the same thing. They were teaching you some subjects, then there were exams, then they were teaching you some more subjects, then there were some practical exams. So it was similar to your journey in college. But once your training phase is over, you will be allotted a project. Now, in that project, it depends on what project you're in. My project was highly technical, so it was just like a bomb on us in initial few days. For every problem that comes to us, we had to run to our seniors to ask for solution. So there we learnt with experience. Nothing was spoon fed to us. So that was a very difficult task to be done in Infosys. But at the same time, we enjoyed it because over the experience, we also mastered that particular team. So that was good. But there are few projects also which are very simple in such multinational companies. You will enjoy doing that task. It is very monotonous, just simple tasks have to be done. So once you're into the project, it completely depends on what project you get. But in either ways, even if it's a simple or a difficult project, there are team members who help you because they have also been in that particular scenario before. So they understand. So they will help you out and it will be a smooth process, no doubt. You also have to show some effort in understanding that job. But the training phases in all such multinational companies are just the same as your engineering exams and everything. They're just very same. So that phase was, in fact, it is even better because there are multiplexes and there are shopping malls, and it is like a tourist destination, especially if you go to Infosys Mysore. If any one of you gets a chance to go there, at least you go for the training phase and you enjoy the scenario there, enjoy the places and come back. I would suggest that. That's one in one places of tourist destination to having it's worth watching. So that is even better, I would say.
A question based on what you taught us today. Basically, you
Hmm.
told about ISO model, in which in the
Hmm.
data link there we are checking if there is any error or not. But is it
Hmm. Hmm.
sufficient? Will it be sufficient? Because they are lost to check if there are any
Yeah, yeah,
errors
yeah.
or not.
That's what I mentioned. It is not at all sufficient. That is just a basic check, like parity checkers and cyclic checker. That is just to check if the bits on the way were not hampered or anything. But that is just a minor checking to filter out the errored packets. That's it. That's the basic checking. The internal hardcore checking you have to do on the application level. Once you get the data, when you open all the packet headers and you get the data, then you have to do the internal checking that you have to design at the application layer. So there are many protocols for that also, for the encryption, decryption and all that. So that kind of security you can implement at the application layer. This data link layer is just to filter out the packets, because there's so much of data in the network that all packets going through advanced scrutiny will be a lot of time consuming, and that will create a lot of delays. So this is just one level of filtering that is done at the data link layer. That's not enough for highly reliable communications.
Thank you for answering my questions. I hope to have such kind of interactive sessions with you.
Yeah, yeah, sure, anytime.
Good evening, ma'am. My next question is what is the exact procedure behind changing the MAC address?
Changing the MAC address.
Yes, ma'am. Yes, ma'am.
Okay, so as far as I know, the MAC addresses are hard coded on your device. So I have not delved into the way how to change MAC addresses. So I don't know the procedure. I'm sorry for that. So this one I won't be able to answer you. But I don't even know if there is anything that exists, something like that.
Okay, it's okay. It's fine. It's fine. Hello, ma'am. Good evening. Hello. Hello.
Are we audible?
Hello.
Hello, ma'am. I have one question. Like, how was your teaching experience in IIT, and how did it get boosted? Like, what happened there exactly? How was your experience? Any uh, any kind of uh, any kind of
Could you please
suggestions made you
could
to
you please
get
repeat
boosted?
the question? I lost the connection in between.
The question is,
Hmm.
how was your experience in IIT, like teaching experience, and how did you get boosted with there, like with there?
How did you get what?
Boosted, like as you said, like I got
Acha, acha,
boost
acha.
from
Okay, okay.
IIT and all.
Yeah, yeah, yeah. Okay, so what I meant was that I have learned my bachelor's and master's in government engineering college. So there, the students are not so much excited and so much involved in learning more than what is taught to you. Okay, they just stick to the syllabus and they are not extraordinary people. So when I joined IIT as a teaching assistant, my task was only to assign them lab assignments and then do their corrections and everything. So when I was correcting their lab assignments, I could see that apart from only solving the lab assignments, they themselves came up with some new things like, ma'am, this could also be done. This, whatever you have said, that could be done in this manner. So they were very curious and very inquisitive of doing things on their own, which which were not only being spoon fed to them, you know. So that's what made me realize ki even I have that talent of this knowledge and talent which I also should use to something more innovative. Like how they are thinking, their way of thinking was extremely extraordinary. I've never seen such brains in government college of Goa. So this was in fact IIT Goa. So I can imagine what will be the state at IIT Bombay and everything, where there are highly brilliant people there. So that's what made me realize that even I should do something with the knowledge that I have gained, rather than just, you know, mugging up and just sticking to the syllabus and only doing the tasks assigned to us. The really inquisitive and curious brains at IIT, you have to see that boosted me, that they were thinking about every problem in maybe 5 to 6 other different directions. Like we could do this as well, why not this? And when I was telling them one solution, they were then and there they were coding it and solving it out, and they were like, no ma'am, this can't be done, but this can be done. They in fact were giving me suggestions. So their way of studying and their involvement really triggered something in me, that even I should make use of my knowledge and do something better for the society. So that's what. And the environment at IIT is, my god, it's like everywhere you have brains roaming around you. So that also motivated me to go for PhD in that area, that environment, rather than doing PhD from any other government institute. So that's what boosted me to join for this.
Hello, ma'am. I have one more question.
Mm-hmm.
Audible?
Yeah, yeah.
Like, what are the different ways of exchange of
Exchange of.
different ways
Hello.
Hello.
Hello. Yeah. Can you repeat the question?
Yes, ma'am. My question
Hmm.
is, what are the different ways to exchange of data?
Exchange of data.
Is there any different way? Exchange of data.
Different way in the sense data is exchanged. There is packets. The packets of data are exchanged. There are different protocols like HTTP, HTTPS. Based on your requirement, you have to select that particular protocol. There is SSL. At the application level, there are many protocols available. So if you want your data to be highly encrypted, then you have to use HTTPS. Or you can also create a VPN, that is a virtual private network, so that nobody else can get a hint of what is happening with your data communication. That's highly secure data communication. So all that kind of different application protocols are available, by which based on your requirement you have to go ahead with that. The most simple one which we use on our Google is the HTTP one, which is the public one, which has no encryption and all. So such kind of data transfers are there.
Thank you, ma'am.
Yeah, welcome.
Hello, ma'am.
Yes. Hello.
Ma'am, I would be grateful if you could share with us how you have kept your focus rooted so much so that you're doing PhD. And as far as I know, doing PhD is not a small thing. It does require much determination and willpower. So could you please tell us as to how we as students can keep our focus consistent?
Okay, so what I would say here is to keep your focus consistent, first of all, you have to love what you're doing. So, as I mentioned to you, when I was doing bachelor's in electronics, I was not at all focused because there were some subjects which I used to hate. So, that's when I decided I will not go for higher education. But that was a wrong track actually. I should find out something that keeps me engaged in every subject. Like in your case, your utmost goal right now has to be clearing your graduation with good percentage and good marks. So to do that, you have to show your keen interest in every subject. Find out something in each subject that binds you to that, that attracts you. All the subjects won't be as interesting as any one which you love. There might be some subjects which you are just mugging up and going for the exam just for the sake of it, but then that will demotivate you as well. So find something that attracts you in every subject, some small thing. Maybe if you are not interested in that subject, check out some YouTube lectures, check out what other institutes are doing in that subject, who are their professors. Go and mail them that this is very difficult for us, could you help us out. Check out other PhD scholars working in those domain in other institutes, so you can get help from every point. Now on YouTube also there are a lot of channels where they teach every subject in a very easy manner in Hindi and all. So find out certain things which keep you engaged to your subject. So as of now, just love what you're doing, so that love will only originate if you have interest in that. So to develop the interest, keep on asking questions like how is this, or how can this be understood in a better way. Try to do some hands on in that, so that you come across more problems and more solutions in that. So find out ways by which you will love the subjects, and that's what will keep you going in this. That is why in my PhD also I have chosen a domain which is a blend of electronics and computer science, because both the subjects had some few things which I used to not like. So if I take electronics only ahead, then also I would be bored. And if I take computer science only ahead, then also I would not be interested. So I chose something that would keep me going. So that's how you have to find your interest. And right now, since you have no other option, you have to study all the subjects allotted to you, then you keep try out some techniques of developing interest in those subjects somehow or the other. Okay, so that's how you can keep on going with this flow.
Sure, ma'am. Ma'am, I have another question. Ma'am, seeing your academic records, we are thoroughly inspired. Here, lots of us would want to know as to how you would manage your busy schedule and how you would prioritize things on a daily basis.
Okay, first of all, thanks for being inspired by my record. And now, what I would say is that I also have other interests like you guys. Like, I am also into some other cultural and other activities which are more interesting for me as compared to studies. But then, one thing I have noted is that you have to every day dedicate a few hours for your studies. Like as of now, since it is work from home, I dedicate around 5 hours per day for my research studies. So based on your interest, you have to dedicate some hours. Now for me, the timetable concept doesn't work because I like traveling and I like cooking and stuff like that, other things also. So dedicated timetable will all get jumbled up based on my schedule. So I dedicate time of like couple of hours. Like at the end of the day, I should complete those many hours in my research. That's what I dedicate. So I think you all also should dedicate few hours per day. That may be any time. Sometimes as per the timetable, if you have written that in the morning you will study, sometimes you are not in a mood of studies, and that is waste of time to study at that time when you're not in mood. Instead, don't go to study, just watch something on YouTube or watch some web series and enjoy that time instead of wasting the time in studies, because anyways you're not going to understand if you're not in the mood. So that's the way you have to deal with your moods. You have to figure out when you will grab most of the part in your studies. So you dedicate a number of hours. At the end of the day, those many hours you have to complete your studies from. Or rather, you can dedicate some part of your syllabus, like I'll finish this module today or something like that. So either the number of hours or a section of your course, anything like that. But I would personally suggest don't allot hours or allot specific times, because sometimes that doesn't work and then you might get demotivated. So this is what works for me. So that's what I would say. You can manage or prioritize as per that.
Ma'am,
Yes.
I have heard that in IIT, time management is a critical factor. So, you being a former IIT student, how did you cope up with the increasing plus hectic assignment load? Because I guess there were loads of it.
Okay, so I'm not a former IIT student. I am currently doing PhD in IIT. But then I have the answer to this. What happens is in IIT, you have all the resources at your hand. You have the labs, you have your rooms, you have the internet resources, everything. So, all the 24 hours in your day, you can do your assignments and everything. So, when you're at home and studying, that's a different thing. But when you're at such institutes where you're given access to anything at any point of time, you have to find out the time that you allot to solve each assignments. Like I have seen students who don't sleep till 5 in the morning and all to complete their assignments, but once the assignments are submitted they sleep for the whole day. So all that also is there. So accordingly you have to manage, because you have all the resources, you have the labs, you have the wi-fi connections. So when you have the resources in hand, managing all the deadlines is very easy, I would say. That only needs a willpower from your side. If you're ready to do it, you're ready to invest and sacrifice, it is up to you. You can do it very easily. So you should not take it as a strain or anything. All the deadlines you have to meet on time, by hook or by crook. You stay up late at night or do something, but once it is done, you have to relax also, so that you're charged up for the next deadline. So it is that way. I've seen people managing at IIT very well. Whenever there are cultural events, they enjoy like hell. And when there are technical events, they slog like hell also. So they have that way you have to manage well all the resources. Yeah, that's it.
And ma'am,
Hmm.
one of my friend who is studying in high school would want to know how to maintain consistency in marks.
In marks.
Yes.
Okay, so that is the same thing as I mentioned before. You have to find out interest in every subject that you're studying. There will be consistency in marks only if you consistently study all the subjects. So only the subjects which you love, you might get like 100 on 100, and which you don't love, you might get 50 on 100. So it should not be like that. Even if the subjects that you don't like, you have to find out certain loopholes in them which might interest you. You have to find out more about that subject where you can express in your own words or anything. There will be something in every subject that might be interesting. May not be the entire subject, but something that might click you. So you have to just find that one point to just cope up and cross that cutoff. I would say at this point of time, getting first ranks and highest and 100 on 100, all that era is over now. You have to just concentrate on clearing all the cutoffs and clearing placements and everything. And that is how you should crack right now. That should be your goal. So just find out interest in every subject that keeps you going to and attracts you to read those again and again. So that's the thing.
Thank you, ma'am, for that clear doubt. We have Sameer who has a question.
Okay.
Good evening, ma'am. I'm Sunil.
Good
I wanted
evening.
to ask one small question, ma'am. Is there a career path that someone in this position would be expected to follow? Like, I currently am in second year, so or anybody in this current position, if you would give some suggestions as to how we can become better network engineers in the future, something.
Okay, so if you're planning to be network engineers in future, then I would say that this is the right time. You have to keep on studying more and more about the CCNA and CCNS exams. You better clear them. That is like the entry point. Like Cisco is one of the major companies which have proper CCNA trainings. These trainings are more than enough for you to know in and out of networking. So if you want to be networking engineer in the future, right from your second year itself, you have to focus on answering these exams and clearing them. And then you can opt for jobs at Cisco. So once you're into it, then jumping from one company to another, there are many companies which like offer you jobs which are like you earn like anything in other countries like Palo Alto and all. These companies are very good in paying you, but then such entrance exams of networking you have to clear. Then even if you want to opt for Juniper, then there is JNIS, JNCIS certifications which I have cleared. So those also you can read about and clear these exams. So these certifications at your level you can go on clearing so that you are at a good position to answer their interviews. That should be your say now.
Thank you, ma'am. I just have one more question.
Mm-hmm.
Is it possible to have, by some way, is it possible to have an error-free network flow?
Okay, so as I mentioned, you can have a VPN network. So that causes that is like encrypted data flows through that network. So you cannot really say it will be error free because now attacks are possible anywhere. That is my PhD research. So even on your own laptop, you handling it also somewhere from the cloud, something can happen that causes attack on your system. So highest possible encryption can be achieved, but it cannot give you 100% guarantee that it will be error free. Okay, so at your side you can try to make it reliable, but you cannot guarantee that. So that is itself a research area to check for highest security. So that you cannot guarantee.
Thank you, ma'am. That was a really helpful answer. I have this last doubt. How
Okay,
can we have an efficient program for the preparation of grade for the current students in engineering?
sorry, could you
And
repeat that question?
a current schedule or a plan which is to help for the further uh, preparation of gate examination.
Okay, for the preparation of gate exam. So you guys are in computer science, right?
Yes, ma'am.
Okay, so when I answered my gate, I had my bachelor's in electronics. So I wanted in and out of computer science subjects. So for that, I had taken coaching. So I had taken the coaching of Ravindra Babu Ragula, and I was doing those sessions. So if you're comfortable with your college reference material and college teachings, then I would say right now whatever is being taught in your classes 100% focus should be on that, and after your classes you have to go on revising your previous subjects. So for that, I would say you every week you should try and check for sample papers and most asked questions and everything, and focus more on that, because gate majorly deals with that. If it is known that these are the areas where the questions are mostly asked, then it has to be asked. So gate always follows that pattern. And as I said, networking, especially the IP addresses and subnetting and all those questions are generally asked a lot in gate exams. So since you're already studying your undergraduate programs, you won't have much time, dedicated time to prepare for gate. But then you can find out such loopholes, like which are the majorly asked questions, which are the most important subjects for gate exam, and only focus on that after your working hours. So during your working hours, focus completely on your teachers, so that you don't have to revise it again and waste more time on that. So that you dedicate for your current subjects, and after your working hours, you can dedicate for your previous subjects and for the mostly asked questions. You can also take online references that is available. Like for me, Ravindra Babu Ravula was the best, because I didn't know even C of computer science apart from whatever was taught at Infosys. So I opted for that, and I would hands down any time dedicate my clearing of gate to him. Within 3 months, I studied all that what he gave, and it was really too good. So if anyone wants that, can also go for that. That I abide by that. Yeah.
Ma'am, and then there's this last question, or one of my observations I had.
Mm-hmm.
This Wi-Fi repeaters. Once what happened is there was a crisis in which we had only one LAN cable working in the entire LAN. So we
Okay.
had taken our Raspberry Pi and then created a different Wi-Fi repeater along with the Raspberry Pi, in
Okay.
which we redirected the entire network so that the Raspberry Pi acts as a hub.
Okay.
So, what is your opinion on this? Whether is this a efficient solution, or do we have any other better solutions at the crisis moment?
According to me, this looks good that you have managed with the Raspberry Pi as another hub, because a similar situation had occurred in our campus as well in GEC, and we used a zinc board and created that as another hub. So similar thing I have also used. So as of now, I can't think of another idea, but this looks sounds good. So did you face any issues with this?
No much issues were observed, ma'am. Everything was stable. And then, but then if it is connected to multiple devices, like more than
Mm-hmm.
10,
Mm.
the speed was reduced. Nothing
Yeah,
much.
yeah, yeah. Mm. So I think dedicated hub would be the only thing. But then
Yes.
this sounds like a jugaad, so which we
Yes.
also used to do. So it's yeah, I think I can't think of anything more right now. So
Yes.
that is fine.
Any practical projects which fascinated you during your college days that you would like to share?
Okay, the one thing that fascinated me in college days was, surprisingly, being in electronics, I was more fascinated about software projects. So I was more into like detecting forgeries in images, in videos. So I and another group of my friends, we were detecting those forged images, like in criminal courts and all. When you show certain photos as evidences, you can detect if it is forged or not. So we were coming up with new texniques with that, even in videos. So that was one thing which was fascinating me that time, like something which could be used in law and order. So similar thing I'm doing now for my PhD research area also. Security also deals with showing what is the correct thing and what is the hampered thing. So such things always fascinated me, but nothing which was close to electronics that time also, and even now. So yeah, I won't be able to tell much on electronics. Though I am doing a project right now, some digital lock or something. So that also I need to do deep into, but more of computer science and software projects interests me a lot.
Ma'am, what's your operating system in your computer?
I have Windows and I have the Oracle VM, and on that I have hosted Linux also. So I'm using both.
Ma'am, which do you feel comfortable during using networking?
For networking, I would suggest Linux is better because you need to do socket programming and everything. So Linux would be better because during our master's days, all the Linux hands-on networking hands-on we had done on Linux. Actually, it depends upon what are your assignments in the lab. Because if you're majorly dealing with Wireshark captures of packets and all, then Windows also would do. But if you're actually doing socket programming, then Linux would be better.
Yes, ma'am. The PCs and the one which we work on is like we partition the disks and then we install Linux in it, which is like, quite better than installing in the virtual box.
Yes, yes, that is anytime better. That on the lab systems, it is better to do that
Yes,
because there are certain softwares which don't work in virtual environment. So it is always better to partition the disk.
this is what I feel now. Thank you for the questionnaire session. That was the most interesting part of the entire talk. And
Thank you
here
so much for the interactive session. That shows that you all were involved in whatever I was speaking. So it was a good part of it.
I request Indraja to take care of the word of thanks. Good evening, everyone. We have now reached the end of today's session. I take this opportunity to thank Ms. Pavitra Bhade on behalf of Edwin's Lab in Alva's Institute of Engineering and Technology for conducting this wonderful session. Thank you, ma'am.
Thank you so much for giving me this opportunity. And I look forward to more interactive sessions. Whenever you all are in need of anything, you can contact me. Spurti knows my contact details, so you can ask her anything with respect to computer security or any networking issues. You can try and contact me, so I'll be there. Okay, we can have a discussion.
Thank you, ma'am. Thank you so much.
Thank you so much. Okay.